for exercise 2C, we're going to consider 2 points. I'm going to call them the first pair, x1, y1. Notice that is a subscript, not a power. It's down the bottom. And then we're going to have x2, y2. And we're going to find some information about these points, and this is called linear coordinate geometry. You've done it in year 10, you've done it in year 11, so this is just a quick bit of revision before you go and practice those questions. So to find the distance between 2 points, the formula tells us that it's the square root of y2 minus y1 squared plus x2 minus x1 squared. That's not something you get on the formula sheet, that's something you have to know. But it makes sense because if we do y2 take away y1, that gives us this distance. x2 take away x1 gives us this distance. So this formula is simply Pythagoras' theorem. The midpoint of those lines, we add the x coordinates together and halve them. We add the y coordinates together and halve them. So the midpoint of a line segment is given by that formula. And the gradient of the straight line, you've seen this before plenty of times, it's y2 minus y1 over x2 minus x1. We've done that to death. And to get the equation of a straight line, there's a few ways. A straight line is y equals mx plus c, where m is this gradient and c is the y-intercept. So what we usually do is just substitute a point in, either x1, y1, or x2, y2. Doesn't matter because they're both on the line. You can also, you might see a formula, y minus y1 equals mx minus x1. That's another way of doing it. So it doesn't matter whether you use this one and then substitute or whether you use this one. So there we have some handy formulas that you just have to substitute in the values that you are given and all things that you've done before. If we want to find the tangent, you might just remember this, m equals tan theta. Gradient is the tan of theta, where theta is the angle made with the positive direction of the x-axis made. And we'll draw a little diagram. If we've got a straight line, this here is theta. And it makes sense because the tan of theta is the rise over the run, m. This we can also think of the opposite and the adjacent. So it's just a SOHCAHTOA. It's tan theta equals opposite over adjacent because opposite is the rise, adjacent is the run, but you just might choose to remember that formula. When we have perpendicular lines, let's think first of all what they look like. I'm going to do one line like this, and a line perpendicular to that would look like that, and this would be a right angle. So what we know is if we get the gradient of the first line, which I'm going to call M1, and the gradient of the second line, M2, if we multiply M1 times M2, it equals -1. But the way we've probably talked about it is you flip and change the sign. So what does that mean? If the gradient of M1 was 3, the gradient of M2 would be, flip it, 1/3, change the sign. If the gradient of M1 was minus 2/3, M2 would be, flip it, and change the sign. Negative becomes positive. So let's do an example. So we've got our 2 points. I'm going to call them x1, y1, and that's -2, 6. And x2, y2 is 4, 7. I know you don't want to write it down, but if you write it down, it just saves you making errors, hopefully. So what's the distance between A and B? Let's have a look. Here's our formula. y2 minus y1 squared plus x2 minus x1 squared. 7 minus 6 squared plus 4 minus -2 squared. So what's that? 1 squared, 4 plus 2 is 6. So that's just going to be 1 plus 36. I'm going to say that that is square root of 37. Let's have a look at B. The midpoint. Well, that is x1 plus x2 minus 2 plus 4 on 2. And then y1 plus y2, so 6 plus 7 on 2. So that's 2 on 2, which is 1, and 13 on 2 is the midpoint there. What are we doing for C? The gradient. I'm going to pop it in here. y2 minus y1 squared, y2 minus y1, 7 minus 6, over x2 minus x1, 4 minus 2. 7 takes 6, 1. 4 minus 2, 4 plus 2, 1/6 is the gradient. Let's have a look at D. I don't know whether I've done this in the best spots, but anyway. The equation of the line. So I know the gradient is 1/6, so it's y equals 1/6 x plus c. And then I can choose either this point or this point to sub in. I'll choose the first one just because I can. Y equals 1/6 times minus 2 plus c. And y was, if I'm using that first one, y is 6. So 6 equals minus 2, 6 plus c. Well, 6 equals minus 1/3 plus c. So if I add that to 6 or 1, so I get 6 and 1/3 equals c. So y equals 1/6 x plus 6 and 1/3. And that doesn't matter whether it's mixed numbers or an improper fraction. All going to be the same. And what's the last one? E. I'm just going to insert a page here. I'll make sure I do one for you. E is find the equation of line parallel to AB. So if it's parallel, it still has the same gradient. So it's going to be y equals 1/6 x plus c, because parallel, same gradient. But we're going to put this 0.15 in this time. So 5 equals 1/6 times 1 plus c. 5 equals 1/6 plus c. 5 take away a 6 is 4, and 5, 6. So y equals 1/6 x plus 4 and 5, 6. And it's still going. What's F? Find the equation line perpendicular to AB. Okay, so the gradient of the line perpendicular, if originally it was 1/6, now it's going to be -6. Flip it and change the sign. And it passes through the midpoint of AB. So the midpoint of AB we found in B, which was 1, 13 on 2. Right, so that's the information we've got. So we go y equals mx plus c. 13 on 2 equals -6 plus c. 13 on 2 equals, I'm going to make this minus 12 on 2 plus c. 13 plus 12c equals 25 on 2. So y equals mx plus c. So now you can have a go at those questions in 2C that are all revision from last year.